Hey everyone, so today I want to talk about something called fast string matching. So lately, I had a client who came to me and he works in real estate, and he spent a lot of time matching between addresses, between two data sets of him, or even more data sets that he has. And it takes him many hours, like 40, 50 hours, sometimes more, just to look for some files or look for some addresses and try to match between the two data sets that he has in Excel files that he has. And it takes him a very, very long time. And it's frustrating. You have Excel files, you have many mobile numbers, Excel, addresses, names, and you need to figure out what's updated, what's not updated, and so on. So he came to me with a question like, can I help him with this? So I told him, yes, there may be a few options that may help. And one of those options is string matching. So string matching, like the usual and the old and good FuzzyWuzzy, was the um, go-to technique. And usually like FuzzyWuzzy like takes two strings, two words, and so on, and just tries to match them between the two, and it gives like a score between 0 to 1. Usually what it does, it looks what are the differences in letters between each words, for example, and how many steps that it need to take from one word to get to another. Like you need to delete one letter, add one letter, it's already two actions, and so on. And based on that, it gives like score. But you have different type of scores, of course, different type of ratios that it can give you. So it really depends what you're looking for. But the real problem is like when you have big files with thousands and thousands of addresses or names or descriptions and so on, it starts to be very, very slow, because it has to look again and again inside these data sets, inside these Excel files, and look for the best match. And it does it for each and every word you want to look for in this file. So it takes a lot of time. So someone came up with a new model called rapidFuzzy. It's not very, very new, but it's already something that works very, very well for production. So let's look at this real quick. So this is called rapidFuzzy, and you see that we have different types of ratios that we'll see immediately. But for example, we can see that you just import fuzz from rapidFuzz, and then you can look for the ratio between this is a test and this is a test with exclamation mark. And you see that it returns, okay, this is the similarity score. It has 96.5% similar. Yeah, so this is like, okay, one action. If you remove the exclamation mark, they are exactly 100%. But since you need one action to get from A to B or from B to A, then it removes several percentage from the matching score. But you also have partial ratio, where you don't need the whole thing to be exact, but at least a certain percentage of it. So that's why you get 100%. And you have also token sort ratio, token set ratio, weighted ratio, and so on. And each of them can serve something different purpose, depends on the project you're trying to make it work, the project you're working at. Yes, and that's it. And you also have some benchmarks between the old and good FuzzyWuzzy and the rapidFuzz, the new method. And you see that the number of word pairs evaluated per second, the larger the better. So you see, like, you can see have 6 million, almost, or even more words pairs per second compared to FuzzyWuzzy, which only 480,000, which is a huge difference. It's much faster, and it can be used in production very well for bigger data sets. But you can also see that it also uses like two loops, right? You go from sample in samples for word in words, and then score sample word. So it's a double, so it's two for loops. It's pretty slow. It depends. You don't need to use only word, of course. You can use a sentence instead. But they also say that you can use cdist, and cdist, if you don't know what it is, It's from SciPy, and it's compute distance between each pair of the two collections of input. I think it's like a sort of a distance matrix, if I recall. But it works a lot faster. As you can see, it's 135 million. You don't use for loops in this case, so it's way faster. So for example, what I did for this client of mine, so I built, for example, this function called find best matches, and I have a target dataset and a lookup dataset. So in the target dataset, I have all the addresses and names that I'm interested to look for in the lookup dataset. Okay, so that's what I'm using for, and there's also something else called process, and it's also taken from fuzzy ratio. If you can see here, rapidFuzz, you have process. So this process, you have a very interesting function there, an interesting method that you have there. Let me go back to it, and it's called extract1, which what it does is basically extracts the best match, the best address match in my case, from all the data sets. So it's already even more optimized than what you saw earlier, and it doesn't use two double for loops. And you see that the target address, it's the address that I'm looking for in the lookup addresses. We have thousands of lookup addresses. I want to look for the best match between the target address and the best lookup address. And I'm using the fuzz ratio, which is the simple ratio that we saw with currently with this method, with this new function module, rapidFuzz. And that is it. It works very fast, and this is the usual way you use it, like use the fuzz ratio target name as the best match address, and then you get the best name score, for example, in here. But it works very well, and especially the extract one really can even enhance the speed much faster. So once I use this this method, process extract one, the process of comparing two big data sets of thousands or tens of thousands become very easy and quick and fast task. Like it can take even less than a minute or so to already have results. So I highly recommend it if you are trying to compare between strings, especially if you have a lot of data. And if you don't have a lot of data, you can still use it, of course, fuzz ratio or just the good old FuzzyWuzzy. It depends on your again the amount of data that you're looking to match. And that is it for today. And if you have any questions, please let me know. And this is it for now. And let me know what other stuff you want me to cover, or you have any questions also about this, about what type of work I usually see and work on, and about Fiverr, because I'm also working on Fiverr, but this is another topic for later. And that is it for today. Thank you very much.